Bless you. Alright, so today we're going to be doing 9.13, which is going to be solving rational equations. So rational equations contain one or more rational expressions. When solving rational equations, identify the restrictions, the values which make the denominator 0, multiply each expression by the LCD to eliminate all fractions, and then use the properties of algebra to solve the revised equation. Eliminate any extraneous solutions which correspond to the restrictions found in step 1. What does LCD stand for again?
Least common denominator.
Very good. And what does extraneous mean?
Not sure.
Yeah, it's the solutions that... Go ahead, were you going to say?
It just can't happen. It wouldn't happen in real life.
Exactly. They might come up, but we reject them because they are not applicable in a real life scenario, or they give us a 0 in the denominator or something undefined. Alright, so let's look at our number 1 here. So for number 1, the first thing you need to do is you need to make sure that all of the denominators are factored as much as possible. What do you notice about x squared minus 1?
That you can factor it further.
Good, and it will factor into?
X plus 1 x minus.
Very good. And what do we call this method of factoring? Bless you.
The difference
Of?
squares.
Yeah, difference of squares, difference of perfect squares, you might hear. So let's talk about how we go about solving these. So the goal in solving a rational equation is to get the denominator to be completely the same, so then you can only focus on the numerator. So here's the method that we use to do that. You're going to look for basically the LCD, or the least common denominator, which will be the product of these two factors. So what you're going to do is you're going to look at the other fractions and identify what they are missing from that LCD. So what is this fraction missing in the denominator? The x minus 1, and you're going to multiply the top by that. And what is this fraction missing?
X plus 1.
So you're going to multiply it by what's missing. Oh, yeah, hang on, I got to do that. Okay, back to the lesson. So basically you're going to multiply it by the factors that are missing, okay, for each one. And this one isn't missing either one, so we don't have to multiply it by anything. And then you're just going to set the numerators equal to each other. So the first one is going to be x times x minus 1 plus x times x plus 1 equals 2. Okay, set the numerators equal to each other. And now you're just going to solve it like any other algebraic equation. We're going to start by using the distributive property. That's going to give me x squared minus x plus x squared plus x is equal to 2. What is x squared plus x squared?
2x squared.
Good. And what is negative x plus x?
Not squared.
0. What's my next step? Divide, which gives me?
X squared equals 1.
Next. What do we do?
The common difference. Perfect square difference.
Yeah, you're right. It would be perfect square difference, but we can also solve. You could subtract the 1 over and then factor it and get the answer. That would work too, but there's another way we could do it. Take the square root of both sides. So those are both acceptable ways to do it. So that's going to give me plus or minus 1. So we don't know if this is a solution yet because we have to look at the initial restrictions. So if we look back to our original equation, what values could x have not been?
1 and negative 1.
Exactly, because that would have given me 0 in the
Denominator.
Very good. So is this a real solution?
No, it's extraneous.
Very good. So there is no real solution. Any questions about that? All right, you ready to try another one? All right, so we look at the LCD. That'll be the product of what the other two denominators have, which is 4x. So this one doesn't need anything. But to get this one to have an x in the denominator, we'd have to multiply by the x. And over here, we have to multiply by 4. So you multiply by what the denominator is missing from that denominator. Does everybody see that? So this is going to give me 1 minus 3x equals 28. So solve. X equals -9, right? Were there any original restrictions on the original function?
0.
X could have not been 0. So is this a real solution?
Yep.
Yes.
Yes. Good. Any other questions about that one? Make sense? I see a few of you writing, so I'm just... Okay. So number 3, first thing you want to do is factor that denominator. How is this denominator going to factor?
X close to x plus 1.
Good, x plus 2 and x plus 1. Because that's going to multiply to give me 2, but add up to 3. Now, are we going to have to multiply this fraction by anything?
No.
But we're going to need to multiply this top by,
1, x plus 1.
good, and the other one's going to be multiplied by,
X plus 2.
very good. Now we just set the numerators equal. X minus 1 plus 2x times x plus 1 equals x minus 1 times x plus 1, or sorry, x plus 2. Now we're going to use the distributive property. And then here we're going to use the distributive property in the form of FOIL. Now we're going to combine like terms on each respective side. This gives me 2x squared plus 3x, that's these, minus 1 equals x squared plus x minus 2. So is everybody with me on that part so far?
Hold on.
Let me know when you're ready. Alright, so it looks like to me we're going to have something that factors into two binomials like most trinomials do, but in order to factor, our equation needs to be equal to what?
0.
Yeah, so we're going to have to subtract everything to one side of the equation.
Did you skip 2 and 4 again?
No, we did them.
Okay.
Well, we're going to do 3 I mean, we're going to do 4, but we didn't skip 2. Thanks for checking. These cancel, 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 and we get x squared plus 2x plus 1. Now we're going to factor this. What is it going to factor into?
X plus 1 squared.
Very good. So what solution would that yield right here? X equals
Negative 1.
-1, because you set that equal to 0 and solve. What are my initial restrictions?
-2 and -1.
So is this a real solution?
No.
No. So it's just a lot of solving, a lot of distributive property, a lot of all that stuff going on. Anyone have any questions about this? All right. So now we're going to deal with literal equations. So what is a literal equation? A literal equation is basically an equation where you have more than one variable and you're solving to isolate a different variable than one that's already isolated. So in number 5, what variable is currently isolated? Good, and our goal is to isolate. Very good. So what two things are in the way of E being isolated here? 2 and
B squared.
V squared. So what one can we get rid of first?
V squared.
Good, and we can do that by reversing division by doing?
Multiplication.
Good, so we're going to multiply both sides by V squared. That's going to cancel out my denominator, and that leaves me with mv squared is equal to 2e. Does it matter if you wrote v squared m? Is that the same thing? If you wrote it the other way? Yeah, because multiplication is, yeah, commutative. So how can we solve for e here?
Divide 2.
Very good. And that's it. That's how you solve. Bless you.
Plus you.
Now, in my time of tutoring for SAT and ACT, which I do a lot, literal equations, I haven't seen one test practice tests come up that the test doesn't have this on it. So this is something important if you're trying to raise your, yes.
Did you mean skip it before?
I just said I wasn't going to skip it and then I did. Well, I was on number 3, so I was supposed to do 4 after it and then I didn't do it. So yeah, let's go back and do number 4. But are you good with number 5 before we go back? Okay. Yeah, I was like, oh, I'll do 4 after and then I forgot. Okay. Alright, so how do I factor this denominator?
X plus 5x plus 3.
Good. Factors of 15 that add up to 8. So in that case, I'm going to need to multiply this fraction by,
X plus 3.
good, and this fraction by,
X plus 5.
good. So that's going to become 2x times x plus 3 minus, this is where you have to be careful with the minus. You have to subtract away that entire thing. So make sure that you don't, forget to distribute that negative sign. So I distribute that negative, I distribute the 2x and the 3. So that's 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. No, you're good. Take your time. So I just use the distributive property. And now I'm just going to combine like terms on each respective side. And if we're going to factor this trinomial, I need to make it equal to
0.
So I need to subtract over the 3x and the,
7x.
well, yeah, with the 7x, but also the 15.
Oh, yeah, my bad.
That's okay. So that gives me x squared plus 4x minus 5 equals 0. And then I'm looking for factors of negative 5 that add up to 4, which are,
X plus 5, x minus 1.
yes, which are going to give me what 2 solutions?
Negative 5.
And,
Positive 1.
very good. What were the initial restrictions?
Negative 5 and negative 3.
So what one is the only real solution here?
Negative 5.
Not negative 5. No, the 1. Oops, sorry. The 1, because that's the only one that didn't get rejected by the restrictions, right?
Oh, yeah.
Do you all understand why that is? Okay. Alright. Let's move on then to number 6, because we already did number 5. Back to literal equations. So in this case, if we're solving for e, we need to get rid of the 1 over mc and the c. How can I get rid of the 1 over mc? How can I reverse subtraction in math? Good, we can add. That gives me c over big E is equal to 1 over mc. Now, what operation can we do with fractions when they are equal to each other? Anyone remember?
Cross multiply.
Very good. You can cross multiply if and only if what is between them is an equal sign. So that gives me E equals mc squared. What'd you say? Probably. It's a very famous equation. Do you know what each of these letters stands for? Anyone know?
I think one of them stands for energy, the speed of light, yeah. Or
Energy is
power.
equal to mass times
Acceleration. Or mass time.
speed of light. Pretty sure. Acceleration is A, because I know F, force, is equal to mass times acceleration in physics. But yeah, not too relevant in this class, but.
Is that like a physics equation? No wonder.
So you'll notice, and the reason we do that, it's actually part of the standard for us to have an equation that is a real world equation for some reason. So yeah, you'll always see it will be a real equation. Alright, so how would we go about solving number 7? Guys, are you with us? You were very excited about it. Okay, so for number 7, how would we go about solving this?
Multiply 2b.
Yeah, so we're going to use cross multiplication. Very good. That's going to give me 2mv is equal to qb squared r squared. Okay. Now from here, we're trying to solve for what variable?
B.
Good. So what is in the way? Q and? Well, and the r, right? Yeah. So how do we get rid of q and r? Well, we can't subtract because it's multiplication, but we can.
Divide.
Yeah, we can divide. So that gives me q times r squared, which is going to cancel. And that leaves me with, I didn't mean to cancel out the, oh no I did. Okay, so we're left with b squared is equal to all this. Now how do I get rid of a square on something?
Square root it.
Square root it. And when I square root it, I have to put a plus or?
Minus.
Good, so that gives me b equals plus or minus square root of 2mv over qr squared. And this would be a correct final answer because the question asked you to solve for b. However, there's one last thing you could do to simplify this. Does anyone know what that is?
You could get rid of the r squared on the bottom.
Good, and we can do that because we can take the r squared out because it's multiplication. So technically speaking, these could all be written under their own roots because it's multiplication and division. If it were addition and subtraction, you can't do that. So technically the answer could be 1 over r, because it's on the denominator, plus or minus all this. Any questions about that? Okay. So this is really the proper answer, but I just wanted to show you how it could come out front. Oh, the plus or minus would be in front of the r. My bad, sorry. I don't know why I put it after. So
Well,
it's
probably because it's already square rooted, right?
well, yeah, but you can't just, it ends up changing to addition, subtraction has to be on the inside. Alright, so we're actually intentionally going to skip 8. 8 is fine, but I think it's just hard when I use this tablet to differentiate capital M and lowercase m and V and capital V, so I don't want anyone to get confused when I try to do it on here. So the homework, I believe it's number 8 and number 9.